Okay, so sorry for that. Alright, so let me just check if you guys are already in front of your computers. So again, just give me a thumbs up. Okay. Alright, so it seems that most of you are already here. So let's now continue this one. Okay, so there is just a correction again. I've just noticed that the I2 was actually flowing in here, okay, on the R3 part. And then the one that they assume as the I3 is the one that is flowing on the R2. Okay, because going in here, as you guys can see, I sub 2 is flowing on the R3. Okay, and then since this is the third current, we could just say that this is the I1 minus I2 or the I3 itself. Okay, so to avoid confusion again, okay, though it will give us a value of, let's say, I3, which is 4 amps, okay, and then I2, which is still I2, but the labeling is incorrect. Okay, so to avoid that one, let me just put here I sub 2, and then this one will become the I sub 3. Okay, just to make that one the same with whatever we have in here, okay, in the redrawing the circuit. Okay, so this one is your I2, okay, which is already 1 amp, and then this is your I3, okay, that will flow on the R sub 2. So using the KCL method, okay, so going in is positive, and then leaving is negative. So we have going in for I1, which is positive, and then going in for the I2, okay, which is my bad, going out, okay, going out for the I2, and then another going out for the I3 is equal to 0. So at this point, KCL at, let's say, node A. At node A, okay, it's A, okay, and then you can now put here the values of your current. So 5 for I1, and then I2 is 1 amp, okay, and then minus I3. So 5 minus 1 is 4, minus I3 is equal to 0. So you can now transpose this one on the other side. So I3 is equal to 4 amps. Okay, so right here we have a current that is flowing, which is 4 ampere. And then right here we have a current that is flowing, which is it's 1 ampere. Okay, so basically 4 plus 1 is also equal to 5. Okay, entering is equal to leaving. Okay, that's basically the idea of Kirchhoff's current law. So that is the reason why we also have this one right here, I1 minus I2. So did you guys get this one so far? Okay, but then again, okay, so do not do this one just like what we have on this example. Okay, so it would be a lot better, like for example, this is your R1, right? So just label that one as your I1. Okay, and then this is your R3, so just label this one as your I3. Okay, so the same with the R2, just label this one as your I2, because in here what happened here is we have the R2 but the current that is flowing is the I3, and then we have the R3 but the current that is flowing is the I2, so it's quite confusing. Okay, so yeah, I just simply followed this one. Okay, but if it's me, I will label this one as your R2, and then I'll label this one as the R3 to avoid confusion. But anyway, since that's what we already have in here, so yeah, that's yeah, the only remedy that we can have. Same with this one. So that's it for the first example. So let me now show to you guys the main advantage of mesh current analysis. So for example, we have three, or we just have this kind of circuit right here. So let me just get this one, this one. Okay, so if it's using Kirchhoff's law, let's see, Kirchhoff's law, this will give you how many equations. So if you're going to put the loop in here, so loop 1, loop number 2, loop number 3, oops, loop number 3, and then you can even have a loop on the outer, okay, like this, and then you can see that this is your uh, loop number 4, loop 2, loop number 3, and then loop number 4, okay. And then in here you can have, let's say, the KCL at node A, and then another KCL at node B. Okay, so all in all, you're going to have a total of 6 equations. Okay, but mostly it will be reduced to 5, since we don't usually use or uh, have another equation for loop number 4. So mostly this one is being ignored. Okay, so you could see that we have a total of 5 equations. Okay, but if you're going to use the mesh current analysis, okay, mesh theorem, so again, we don't consider this loop number 4 because it has loops inside of it, and then we are not going to use KCL anymore, so it's another less 2 equation. So all in all, you're going to have 3 equations only. So loop number 1, loop number 2, and then loop number 3. Naglalag na talaga yung computer ko. Anyway, so yeah, we have 3 equations in total. So 3 unknowns, 3 equations. But unlike in here, we have 5 unknowns, 5 equations. So that is the main advantage of using mesh current analysis. Okay. So in here, first, of course, you have to label everything. So we have this assumed flow of current. So I1, I2, I3, I4, I5, and then the node A or node B, okay, or node 1 or node 2, and then the another voltage source right here. Okay, so if you're going to use Kirchhoff's, you're going to have this kind of equation. So 5 equations, 5 unknowns. Okay, but if you're going to use a mesh current analysis, this will only give you 3 equations and then 3 unknowns. Okay, so that is basically the main advantage of this one. Okay, so let's analyze this one using, okay, I think we don't have a solution for this one. But anyway, let's just analyze on how did we come up with this kind of equation, so that you guys have an idea how did we come up with this one and that one. Okay, so let's start with the loop number 1. Okay, so the one that we've used is the entering polarity, so negative EB1, okay, and then positive R2 times I1 plus I2. Okay, oops, nandito naman na siya. Okay, so this one is quite confusing. Mali nga pala yung ginawa ko. So we've started right here and then jump next in here. Okay, so ganun yung flow card niya. Hindi siya clockwise, but it's counterclockwise. So after this, go right here. Okay, so that's the reason why we have R2 times I1 plus I sub 2. Okay, and then again, the one that is using is the outer. Okay, ganun na lang. Kasi mula dito, ito na yung flow of current niya. Okay, nasa outer. And then outer again, that's why we have positive right here. And then we have another positive right here, since the one that we're considering is the outer. Okay, so uh, that's the main disadvantage if you're using 2 polarities or 2 method. So if you're used to using the conventional method, just stick to that kind of method. Okay, forget the other method, the current method. Okay, if you're using the current method, then stick with the current method. Okay, do not mix them in, in this number, in this another number, or in this another number. Okay, so all in all, kapag conventional ka na, just use conventional. Okay, if you're using a current method, then just use current method. Okay, so in my case, I am not used to using current method. I'm more into conventional method. So that is why if we're going to come up with our own equation, okay, using my own equation also, so let's try compare. So In my case, using the KVL at loop 1, I think it's easy to use this one now, this text right here. So KVL at loop 1, okay, so it will give you the positive EB1, okay, so I'm using the outer, and then negative I1 times R1, okay, and then right here we're going to use negative R2 times I1 first, so it's always positive. So there's no way that this will become negative. So the only one that will be indicated as positive or negative is the second loop right here. Okay, so if you are going to take a look on this one, they have the same flow of current. Okay, so they will meet right here. Okay, and then as a result, they now have the same flow of current. So if they have the same flow of current, then just simply add them. Plus, okay, I2 equal to 0. Okay, so this is now your KVL at loop number 1. Okay, so let me just label this one again. So we have this flow of current right here, and then we have this flow of current right here. So they will meet at this point right here. Okay, so moving on the I sub 2, KVL at okay. So let's start right here first. So we have the I will still consider the outer sign. Okay, just be consistent with whatever you're doing from first. Just do that one until the end, so that you will have the correct equation and then correct answer. So we have here positive I2. Okay. Oops. Yeah, it's always positive. Wait a second. Going right here, and then hmm, nakakalito na kasi ang ginamit is from here to there. Okay, so let's start with the right side na lang, since kapag dito medyo nakakalito. Let's start with this one first on the R4. Okay, so we have negative I2. Okay, so we are now still dealing with the outer sign. So negative I2 times, my bad, negative R4. Okay, times I sub 2, okay, and then they have the same flow of current of your I3, so it's positive I3, okay, and then going right here, we have negative I2 times R3, okay, or R3 na lang muna times I2, okay, to make this one consistent. Hindi na pala consistent kasi nauna yung currents dito. Okay, well, anyway, so okay lang yan kasi multiplication naman. And then after that, we can now go right here. We have negative, still negative I sub 2. Okay. And then right here, we have the same flow of current. Okay. R2 pala. R2, and then the same flow of current, which is I2 plus I1. I2 plus I1. Okay, equal to 0. Okay. So, yeah, that's how we've got this KVL at loop number 2. Yeah, negative R3. Negative R2. Okay. So, were you guys able to follow so far on the second equation? All right, so we now have two currents right here on the R4, and then another two currents right here on the R2. Okay, after that, we can now move on to the last equation. So this one is flowing from this one, go positive, negative, positive, negative, positive, negative. Okay, so again, I'll start with this one right here. KVL at loop 3. And And right here, I will still consider the outer sign. Okay, so we have negative it's still the outer sign, so it's negative I3 times, or R3 rather, times I3. And then as you guys can see, I2 and I3 have the same flow of current, so it's positive I2. And then minus R5 times I3 is equal to 0. Okay, so yeah, that's it for the third equation, or the loop number 3. So are we clear on how did we get this one? So from here, going here on the R4, mali pala to, hindi pala siya R3. So let me just remove this one. It should be R4. There you go. Okay, R4 times I3 plus I2. And then negative R5 times I3. Okay, so let us now try to compare if we have the same result. Okay, so in here, all you need to do to make this one the same with the first equation is just multiply this one by negative. Okay, so just multiply this one to negative, so this one will become negative, and then negative times negative will be positive. Okay, this one, and then negative times negative is now positive. So our equation number one is correct. Okay, and then for the equation number two, we have, where is it, R4? So R4, negative R4. Okay, so we have the same symbols or signs. So this one doesn't need to be multiplied to negative anymore. So take note that, even though you're multiplying negative on the entire equation, so you're not changing anything. So it's safe to do that one. Okay. If you want to have a positive equation by multiplying that into negative, then it's also okay. Okay. So negative R4 times I2 plus I3, and then followed by R3 times I2, which is now this one. And then the last one is negative R2 times I2 plus I1. This one is also correct. And then for the last one, we have here R4 first. So R4. So in here we have a negative. In here we have positive. So all you need to do is multiply this one to negative, the entire equation. So this one will become positive R4 times I3 plus I2. Okay, and then next one is EB2. Okay, so this one will also become positive upon multiplying this one by negative. And this one will also become positive upon multiplying by negative. So R5 times I3, or I3 times R5. So this one is also correct. Okay. So see, even though I have the opposite method, okay, that I've used, so I've used the conventional method, but in here I think I've used the current method, we'll still arrive with the same equation, just a different uh, symbols. Okay. So were you guys able to follow on how did we get those equations? 80%. Okay, coming from mysteries again. Anyway, so you can always go back and then read this one again and then try to analyze everything. So this one, you won't really be able to understand this one just by looking at my solution. So it would be better if you will do this one on your own, okay, using your own paper, using your own pencil or a ball pen. So with that, you're experiencing everything. Okay, so it's a lot easier to learn that way. Okay, if you're doing that one with your own way of analyzing or how to do things. Okay, well, anyway, so that's the advantage of using the mesh current analysis. So we have another example right here, which is the unbalanced Wheatstone bridge. Okay, so we have this circuit right here wherein so R1 is in parallel with R4, R2 is in parallel with R5, and then what else? So after solving those, you can now have a series connection with R3. But of course, we cannot do that one easily, okay? Since this one cannot be solved using an Ohm's law alone. So in here, we have to apply either Kirchhoff's law or mesh current analysis, okay? But of course, the easiest one is always the mesh current analysis. So if you guys are going to take a look at this one, we have the first loop right here, second loop, and then the third one is right here. Okay, because if you're going to consider the Kirchhoff's law, so 1, 2, 3, and then the outer loop, and then the KCL part. Let's say KCL right here, and then KCL right here. It will give you more equations. So that is not a good option to solve this kind of circuit. Okay, so here's now the third loop, okay, which is the I3. So let's now solve this one. So in here, what we did here is the just put the label, okay, of the resistor voltage drop polarities. So we've come up with this polarity, positive, negative, positive, negative. So they have the same flow of current, okay. And then right here we have positive, negative, positive, negative. So this one also the same flow of current. However, in here, as you guys can see, we have negative, positive, and then positive, negative. So we now have two different uh, polarities. So they are opposing each other. So as usual, the other one will become negative, or the other one will be deducted on the other current. Okay, so without a further delay, let's start with the I1 first. So in here, it started with the R2 first, going to the R1. No, going to the R3. So R2, R3, and then R1. So, and in here, the one that he used is the outer sign. So it's positive uh, R2 times I1, okay, which is now this one. And then in here, we have positive R3 times I1 plus I2, okay, since they have the same flow of current. And then in here, we have positive R1 times I1 plus I3, okay. So it's still positive since they have the same flow of current. So I'll give you guys 20 seconds to analyze and how did we come up with this equation. And then let me know once you have already understand this original form of equation. Okay, so anyone who was able to get on how did how did we get this equation? Okay, Mr. Maaba already got this one. Okay, and then Mr. Donato also already got this one. Kunti pa sir, sabi ni Mr. Carlo. Okay. So actually, this is the one thing that you must be expert with when it comes to mesh current analysis or Kirchhoff's law. You know, forming the original equation is the most crucial one. Okay, because if there is a part that for example, you instead of having here a positive, but you put here negative, uh, you know the entire equation is already incorrect. So you will never get the correct answer. Okay, so this is the one thing that you should be careful with. And then this is the one thing that you should always double check, triple check, quadruple check. Then after that, you cannot proceed to the next step once everything is already correct. Okay, so those equation number one, equation number two, equation number three. Because after forming that one, just by applying basic algebra, you will already get this one, and then the simplified form of equation. Okay, so once you're done with this one, and you can now distribute this 100 right here, you will get 100 I sub 1 and then 100 I sub 2. The same with 150, you will get 150 I sub 1 and then 150 I sub 3. And then you can now add similar terms. Okay, and then after that, it will give you this simplified form equation, or the final form equation of the number one. So again, just let me know once you have already understand this part, and if ever that you have a question, so please let me know so that we can verify, you know, whether this one is really correct or no. Maybe this one is incorrect. So who knows, right? But Miss Ginaran already got this one, so very good. What about you, Mr. Maaba, Mr. Donato, Miss Maris, Mr. Gonzalez, Mr. Nathaniel, Mr. Paran, Mr. Mark Jason, Mr. Francis, Mr. Cameron, Miss Gabaldon, Sophia. Okay, 70%. Okay, great. So in here, you really need a lot of practice. So try to solve 5 problems, 10 problems, just to familiarize on how to form an equation, simplify things, finding the unknowns using the simultaneous equation or using your calculator. Okay. So in your exam, so it is completely up to you. Okay. So once you have come up with this equation, and then the other two equations, you can already use those three equations uh, to solve it using your calculator. So I won't be needing the solution anymore. Just indicate there in your solution that via calculator or using calculator. Okay. So with that, I already know that you have used that kind of method. But if not, and I'm not seeing any computation for the I1, I2, and I3, then maybe you have used the simultaneous equation. Okay, so via elimination. So either of those two. Okay, so once you're done with this one, so the same concept with the I sub 2. Okay, but in here we've started with, where did we start? Where is the 50 right here? Ah, ito pa rin yata yung kanina. Ito yung is 1 plus 1 at I sub 2 plus 1. Okay, so this is still the one that we have on the I sub 1. Okay, just more explanations on how did we come up this one. So in my part, again, I will not read this one. I will let the reading part to you guys. Okay, since kapag babasahin ko to, lalo lang tayong tatagal. Alam ko namang marunong kayo magbasa, okay? So I'm just adding, or I'm just summarizing to make our discussion faster and quicker. Okay, faster and quicker, parehas lang naman. Redundant. Anyway, so this is now the equation number 2. So we have here the 100 first, and then 300, and then 250. So R3 first, and then going to R4, and then going to R5. Okay, and then in here, uh, So if we are going to start with R3 and then going to R4, so I'll just assume that he have used the outer symbol, okay, from here to here and then to there, okay. It's quite contradicting with the flow of current, but yeah, since I'm used to conventional methods, so that's my flow of current, okay. But still, I will still follow the symbols that's being indicated here, just to to have the same symbols. So positive 100, okay, for the R3, multiplied to the I2, okay, plus I1, okay. So yeah, that's it for the second equation. And then we have here positive 300, okay, multiplied to I2 minus I3. So why minus? Since again, we have a contradicting flow of current. Okay, so we have negative positive and then positive negative. And then in here we have positive R5, okay, which is 250 times I sub 2. Okay, so again, I'll give you guys 10 to 20 seconds to analyze on how did we come up with this equation. Okay, so anyone who was able to get this one already? Okay, very good, Mr. Maaba. What about the others? Okay, very good, Mr. Donato. Now, if you are confused with, how it was done on this example, so you can do it your way, okay, but just multiply it to negative at the end just to compare if you have the same result, okay, because either way, it will give you the same answer or the same equation, okay. So if there is a part that you're different with this one, let's say on the I2 or I3 or I1 or I2, then meaning maybe you did something wrong or incorrect. Okay, so just try to redo it again and until you'll arrive with this the same equation. So again, after that, just distribute this 100 on the I1 and I2, and then the 300 on the I2 and I sub 3, and then combine similar terms, and then it will give you this simplified form of equation on the I sub 2. Okay, so again, let me know once you already got this one. Okay, very good, Mr. Donato. Okay, very good, Ms. Kinoran. Okay, so moving on to the next one. Okay, so more explanations on how did we come up with this one. I'll skip that one already. So moving on to the last equation on the I3. So we're still dealing with the outer sign. So we have here positive 24, okay, minus R1 or negative 150 times I3, okay, plus I1 since they have the same flow of current. And then negative 300, okay, so this one right here, this symbol right here, negative 300 times I3 minus I sub 2 since they have an opposing flow of current. Then same process, just multiply or distribute this 150 and 300. Then you will get this equation right here, and then you can now combine similar terms, and it will give you this final equation for the I sub 3. And then from there, you can now choose between two methods. It's either via calculator or using simultaneous equation. But in my case, once I have three equations or three unknowns already, I don't use simultaneous equations anymore. Though it's still possible, but it is already super hard. But it's still possible, especially if you're an expert when it comes to uh, call this one eliminating other variables just to come up with one single variable or single unknown. But in here, as long as you have the three equations and then they are correct, and then you will get this values of I1, I2, and I3 right here. Okay, so the reference of this presentation came from All About Circuits. So if you need more information, then you can visit this one. Okay, and then as a summary, as well as using mesh current analysis, we can also use node analysis to calculate the voltages around the loops. Again, reducing the amount of mathematics required using just Kirchhoff's laws. Okay, so you can also visit this one. Okay, so it's electronics tutorials. So both of them is helpful. So it's just that they have different examples and then different way of explaining about mesh current analysis. So that's actually it for the mesh current method. So we will stop here for now since we don't have enough time anymore. So we supposedly I will try to finish until the superposition theorem, but we'll just do that one next meeting. Okay, so we'll discuss superposition and then the nodal voltage analysis on this coming Tuesday next week. Okay, so that's all for now, and goodbye and thank you guys for coming. And don't forget to answer your